With the advent of small angle neutron scattering, molecular dimensions can now be determined in the bulk state. A polymer scientist determined the following data on a new deuterated polymer dissolved in a sample of protonated polymer. The values of d sigma by d omega to the negative 1 are given, and k squared times 10 to the power 4 Armstrong to the negative 2 are given. The constant Cn for this system was determined to be 10.0 times 10 to the negative 5 moles per gram centimeter. What is the radius of gyration of the deuterated polymer? What third quantity is implicit in this experiment, and what is its probable numerical value? We can start off with the equation used in small angle neutron scattering experiments. D sigma by d omega to the negative 1 equals 1 over Cn times the molecular weight mw times 1 plus k squared, where k is the wave vector, times rg squared, where rg is the radius of gyration, over 3. So this is of the form y equals mx plus b, equation of straight line. So if we have a plot of d sigma by d omega to the negative 1 versus k squared, then 1 over Cn mw rg squared over 3 would be the slope, and 1 over Cn mw would be the y-intercept. Let's plot the graph. So the k squared times 10 to the power 4 Armstrong to negative 2 goes from 1.00 to 10.1 in values. So I'm going to start from 0. D sigma by d omega to the negative 1 has values from 0.5 to 1.20. So the first point is 1.00 and 0.5. The second coordinate is 3.70 and 0.72. The third coordinate is 10.1 and 1.20. So this is the straight line. So we get the y-intercept as 0.4 centimeter, but our y-intercept is 1 over Cn mw, and Cn is 10.0 times 10 to the negative 5 moles per gram centimeter. So mw is 25,000 grams per mole. Now for the slope, 1 over Cn mw Rg squared over 3. Let's select 2 points from the graph. 1.2 times 10 to the negative 4 and 0.5. 1.2 times 10 to the negative 4, because the x-axis is k squared times 10 to the 4, so we want to write 1.2 times 10 to the negative 4, and the y-coordinate is 0.5. The other point, 5.2 times 10 to the negative 4 and 0.8. So the slope is which is equal to 750 centimeter angstrom square. So that's the slope. 750 times 10 to the negative 16 centimeter cube. So Rg equals slope times 3 times Cn, which is 10.0 times 10 to the negative 5 mole per gram centimeter, times the molecular weight, which is 25,000 grams per mole, and the square root of that. Which is 75 times 10 to the negative 8 centimeters, or 75 angstrom. We can compute Rg squared over mw, the square root of that, which is a constant for a given polymer and which is usually expressed in angstrom mole per gram to the power half. So that would be square root of 75 squared over 25,000, 0.474. For a polymer in the bulk state, it is present as random coils. The end-to-end distance R is given by square root of 6 times Rg. So R, the end-to-end distance R would be 1.16 angstrom. For this equation, A2, the second virial coefficient, is taken as 0. This is because A2 denotes polymer-solvent interactions, and in this case, the polymer is dissolved in the deutero form of the polymer, or the deutero-substituted polymer. So it's essentially the polymer is dissolved in itself.